So welcome everyone to our Routing Switching Essentials class meeting for this week. We are going to talk a little bit about the end of chapter 1 and then get into static routes and talk about those. In particular, what I want to do is go back over some things quickly that I've seen some issues with in NetLabs as we're moving forward. But one of the big things is looking at how a router puts its routes into the route table. Remember we talked last week about administrative distance and metric, those two items, and about how a metric is how you determine the best route within a routing protocol. So if you were out running RIP or EIGRP on this network, you would use the metric for RIP, which is hop count, to find the best path. Now this is kind of a crazy network because there's only one path, all right? And in EIGRP, you would use its metric, which is bandwidth plus the sum of the delays in the links. If you are comparing two routing sources, you use administrative distance to determine which one is better, all right? Now, what I want to do is I do want to jump into NetLabs, and I want to jump into the router here that we have, in this case, R1. And just go through a real quick basic review again. This is user exec mode, so it's just look and see where we cannot make changes. Type enable to get into privilege exec mode, config T for configuration mode. Now, what I'm going to do is set the host name to R1. And in this lab, let's see, gig 01 is 1.0 or 1.1. So I'm going to go, first off, I'm going to set all my passwords, so linecon 0. Login synchronous, so I don't have any problems with anything jumping through. I'm going to just, for me, just do password. In this case, I think it was Cisco con, and I'm just going to do password Cisco because I'm lazy. Login. Line VTY 04. Hit the up arrow 2 times. Password Cisco. Login. Okay. Enable secret class. And I'm just going to do a banner MOTD stay out. It's not a very good banner, but it is a banner. Okay. So at this point, I've really done the basic config on the router itself, other than the interfaces. So let's go into gig 01. And using, by the way, again, remember to do your show lab content so that you can see the content and know what the IP addresses and everything can be. I've reviewed this, so I kind of know it by heart. So I'm going through right now showing you this. But before I do anything, I want to do this. I want to do a do. Remember, do lets me run commands inside of configuration mode that I can't normally run. Do show IP route. And you should see that I have nothing in the route table. Absolutely nothing. I'm going to do debug IP debug. I can't do it that way. Let's do this. Let's do I'm drawing a blank, folks.
What are you trying to do?
You're welcome to help me if you can remember it.
What are you trying to do?
Debug the routing table. Debug
yeah, debug IP route.
I think that's it. Do debug IP route. Let's try it. Nope.
Hit the question mark after. Well,
let me do this. Do debug IP. Should be route.
IP
routing.
Okay.
IP routing. Ooh, my name's Kelly. All right, I've been hit by a truck. My excuse. All right, so now config T. And the reason I want to show you this is because I'm going to int GI 01, and I'm going to go IP address 192.168.1.1 255.255.255.0. And I'm going to do no shut. And what you should see is you should see this added into the route table. And here you go. You can see now network route table add 1.0/24 via connected metric. So now if I do a do show IP route, you now see that I have one route in the route table, which is a connected route via gig 01. So as soon as I added the IP address and did the no shutdown command, because remember, interfaces on a router begin their life shut down. But as soon as I did that and it came up, the route table went in and added that into the route table. Now if I do the same on the other side, if I go to int gi00, do IP add, and on this side it's 192.168.0.1, 255.255.255.0, and I do a no shut. It will then add the other route, which is the 192.168.0.0 network /24 into the route table. And so I can do a do show IP route, and now you have the connected route off of gig 00, which is the 00 network, and you have the route off of 01, which is the 10 network. I can now go over here and pull over PCB. You'll see it's got an IP address of 03, and I can ping all the way over to PCA, which is 192.168.1.3, and it works. And vice versa, I can go over here and ping from 192.168.0.0.3. So I am pinging across this very simple network from PCA over to PCB. You'll notice the route table, obviously, was built by connected routes. That's all you're going to have in this particular setup. All right. But even if you did not have connected routes, okay, if you were using a static route, those routes would go in the route table based upon being added either dynamically or statically. Now, one of the things that's important to note, watch this. I'm going to shut this interface down. You will then see that the route table deletes the route. For the purposes of this class, the router will not put any route into its route table that it does not have a route to or does not have a connection to. So if you're seeing this, you can see that I lost the 00/24 network that was on this particular side. Many times I see students have that issue. Control A brings me here, no shut, and do a no shut, and it will add it directly back in. Now I can do a static route. It wouldn't make much sense here, but let's imagine that I add a router over here on the other side of PCB. I could add a route to IP route 172.16.0.0.255.255.00, and it's available via 192.168.0. and almost 0.2. Okay. And it helps if you put the word route in, IP route, okay, and leave a space in there. I'm flying by the seat of my pants here, folks, okay. But notice what it did. It did add that route into the table because it knows how to get there. So if I do a do show IP route, you'll see there's now a static route that has been added to the 172.16.0.0 network via 172.16.0.2, which is off of gig 00. That's the only reason that would actually go into the route tables, because I had it go off of the network that I was already connected to. So routes are added and removed from the routing table based upon configuration of static routes, dynamic routes, or just adding IP addresses onto interfaces. That will give you your connected routes. Does that make sense? I saw some problems with folks putting in IPv6 addresses on this first lab that I graded. Remember, IPv6 addresses are just IPv6 address and then the address and link local, and just make sure you put in unicast routing. Most of you were fine, but just be aware of that. Also, remember when you're putting in your passwords and those things, make sure you don't forget that if you put a space after the password itself, it will that will be used as part of the password. So if you put Cisco VTY pass space, then that is the password. Some of you had some issues with that. So questions about adding routes into the route table? Again, go ahead. Great, Keith.
No, I didn't have any. I was going to say no.
Okay. So those L routes, remember, those are just the IP addresses that are actually on the interface, only on iOS 15 or higher. Directly connected are routes added to networks that are connected to the interfaces. So in this case, you would see R1 would have 3 directly connected networks on it. Static routes are added when you manually configure a route, and then dynamic routes are added by dynamic routing protocols. And one of the neat things and the good things about dynamic routing protocols is, or even the route table itself, I do a Control Z here, I do a show IP route, it tells you here what all of them stand for. So L is local, connected, static, RIP, BGP, EIGRP. By the way, you will learn the reason. Excuse me, the reason that EIGRP uses D is because D stands for the diffusing update algorithm, or dual algorithm, that is used by EIGRP to make routing decisions. So D, OSPF is O, and then so on and so forth as you go through it. And you'll learn those as we move forward. Here again in remote entries, you can see that this is where it was learned from, in this case EIGRP. This is the destination network. This first item is the administrative distance of that route. In this case, administrative distance of EIGRP is 90. The second item in the brackets is always your metric. VIA tells you where you learned this from. So this is telling me that this IP address told me about this EIGRP route. This is how long you've known about it. And this is the outgoing interface. This is how I get to the device that told me about that network. Very important to be able to look at a route table entry and read it, because that's something that will show up over and over throughout your use of Cisco equipment. Again, I'm not going to spend much time on these directly connected, because they are there and they come up when you put an IP address on the interface and do a no shut. You can see here again, it gives you the network, tells you it's directly connected, and then it tells you the outgoing interface. So a pretty simple entry in the route table itself. Skip that. Here again, this is just IPv6, exact same thing, showing you connected and where it's connected to, in this case 00. So IPv6 is not all that wild. You don't have to worry about it being a weird thing. It's just longer addresses, quite honestly. So static and default routes. Let's talk a little bit about why we would use static routes. And this is, go ahead and start in information in chapter 2, but static routes are best if you have a single path, or if you're wanting to reduce the use of network resources and router resources. You can see here, in this particular network, one of the nice things about this network is it's very simple. R2, okay, could be configured with 2 static routes, one to the 10 network and one to the 11 network, especially if you knew you were not going to add any more routes off of R1. R1 only has one way that it can go. Okay, so it could have a static, what's called default route, that would send all of its traffic it didn't know how to get to. So anything it wasn't directly connected to would go over to R2, and R2 could handle it. And then R2 would have a default route going out to the internet. Now, static routes are very easy to configure. It's IP route, network, the mask of the network, and then either the next hop IP address or the exit interface, or both. You can do both, which is called a fully qualified static route, when you do both the next hop and the outgoing interface. We typically only do that on links that are Ethernet or multi-access links. A default route is similar to this, but you use the quad 0, which says anything I don't know how to get to. In other words, anything I don't already have a route to, send it here. So in this case, you would do that on R1, so that R1 would send anything it didn't know how to get to R2. R2 would have a default route also, but it would send it up to the internet. And then it would also have a route to 10.0 and 11.0, so it could get over here. And that would make this entire network routable with the addition of 4 static routes, 1 on R1 and 3 on R2. Then you wouldn't have to worry about routing protocols, security. You wouldn't have to worry about routing protocols using link bandwidth. You would not have to worry about routing protocol authentication, any of those things, or configuration, or resource usage, because routing protocols do use memory and CPU on your routers. That would assume, of course, you're not going to add a whole bunch of routes to this network. So here's your example. R1, IP route quad 0, outgoing interface. Pretty simple. If I don't know how to get to it already, send it to R2. Now, I already know how to get to the 10 network, the 11 network, and the 209.165.200.224/30 subnet. You can see here it is. On R2, we're going to go in and put a static route to 192.168.10.0 out S000. So it says to get to the 10 network, go over here, and to get to the 11 network, go over here. And in this example, they don't have the internet up here, so you don't have a default route on R2. In this case, everybody could talk to everybody because you've got static routes. Remember what I said to you, though. What if you did just this and forgot to do this portion of the configuration? I've told you before that each router makes its routing decision based on its routing table alone. Also, just because there's a route to the destination does not mean there's a route back. So be aware of that. You have to be careful because I've seen this many times. You got 2 students working together. One puts the default route on, and the other student forgets to put a route to the 11 network. It's working great from 10, but not from 11 because the R2 doesn't have the 11 route in it. Static route for IPv6 is IPv6 route : 0, which means that's all zeros, outgoing interface. And then it will show you the default route as a static route. And then on the opposite side, you'd have to have 2 static routes going back to the IP address, or they just did this 2 different ways. You can either do it with the next hop IP or the outgoing interface. Either one works, and they just decided to show you both examples. The NUM6 is exactly the same as doing a static IPv4 route. It's IPv6 route, prefix length, the next hop, or outgoing interface. Okay. Dynamic routing is a whole different beast. This is where you go in and turn on the dynamic routes, and then those routes are shared dynamically between the host. And we will see that a great deal more as we move forward in this class, especially with RIP. We're only going to use RIP in this section. And actually, it's kind of funny because nobody uses RIP anymore. But they've actually taken all other routing protocols out of the ICND1 or the CSANT. So it's actually a little easier, I think, because you'll have to learn one routing protocol. Here we have routes that have been learned via EIGRP. You'll learn down the road that this means it was injected into EIGRP from the outside routing source. This is an external EIGRP route. You'll also notice, look, it has a different administrative distance. This is where R2 has taken its static default route and injected it back into EIGRP using a special command. Okay, redistributing static instead of default information originating. So IPv6 works the same way. You got RIP-NG next generation, you got OSPF-v3 and EIGRP for IPv6. You will actually learn how to do all these as we move forward into your scaling and connecting classes. Verifying routes show IPv6 route, and you will see dynamic routes listed. Again, reading it, this means it was learned via EIGRP. This is the network and prefix we're going to. There's the administrative distance, there's the metric, and there's where we learned about it. There's the next hop IP address, and in this case it's actually a link local address, and also the next hop or the serial interface you go out to get to that network. Not the next hop, but the actual outgoing interface on R1. Questions about routing concepts before we jump into static routes? Okay, let me do something here. I'm gonna schedule me a lab while I'm talking a little bit. That way I can jump in there. As you can see, you have a fairly large number of people using the labs now. We've got a huge number of students in my classes right now for instructor training. We've got 65 students in the first 5 classes I'm teaching, and I've got another 75 students starting on Wednesday, so pretty busy. So we've talked already about this, static and default routes. So they're reviewing what we just went over in chapter 1. But why should we use static routing versus dynamic? One of it is that, for the most part, its complexity is very simple with simple networks. However, static routing is not good for large networks, period. That's just, it does not work well in large networks. Static routing will not automatically change for topology changes, but also the good news is you know security-wise exactly where all your traffic is going because you are statically saying this traffic for this network goes this direction. So it is actually more secure than dynamic routing. It is less resource intensive on your router, so it doesn't use CPU, memory, or link bandwidth. And it is very predictable because when you do a static route, the traffic will always take that path as long as the path is available. Now, having said that, typically we're going to use static routing for our default routes in our networks, and we use dynamic routing on the inside. I think people get so enamored with dynamic routing that they think it's the answer to everything. But I'll give you a great example. I had a test one time I had to take, and there was this big, massive OSPF configuration they wanted you to do, and I looked at the network and figured out with 3 static routes I can make everything work. I knew how to do the OSPF configuration, but I just went ahead and did it with static routes. And then told the instructor afterwards, I said, well, look, I said, they tested basically connectivity. Could you ping across it and make connections? And you could. And I said, when it was over, I said, look, I could do this with OSPF, but I did it with 3 static routes. And they just started laughing because they finally figured out that, yeah, that is true. You can do it with 3 static routes. So, you know, I think we learn these big dynamic routing protocols and then decide they're the best thing ever. And in most networks, they are, but static routing does have its place. So when do we use it most of the time? Stub networks. If you've only got one path out, there's almost no reason to use a dynamic routing protocol. If there's a single path, this network right here, all you need to do is put a default route out going to R2, and then have R2 have one route back to 3.0. This is especially true if you're not going to add any more networks behind R1. It makes it very, very simple. So what are different types of static routes? Well, one is a standard static route, which is just to a network. So in this example, a static route would be the route to this 172.16.3.0 network. That's a standard static route. A default route would be the quad 0 route from R1 that says anything I don't know how to get to, go up here. We're also going to talk a little bit about a summary static route, which combines a group of routes into a single route. In other words, we take a group of subnets and we could summarize them so that we can have a summary static route. And then what's called a floating static route, which lets you do some play with static routes and makes a backup static route, which sounds crazy, but it's a backup route that will only be used if the primary route is not, primary static route goes down. It's kind of cool. So here, standard static route. Here's what you have to do. Let me find my notepad. So in this case, on R2, okay, you go to R2, you'd be in global config, say R2 config. In global config, you type IP route. Oops, man, I cannot type today. IP route 172.16.3.0, 255.255.255.0, and then you could either do S000 on R2, or you could do the next top IP address, whatever it happened to be. I would just do outgoing interface. One of the nice things about outgoing interface is it lets you change the IP addresses on those serial links or on the links without having to go back and change your static route. So that would just be a standard static route. You'd then go on R1 and do the IP route quad 0 S000, and you are good to go. So this would be on R1 in global config. All right, and you would have full routing. So you'd be able to get anything here. Let me ask you this: how many connected routes would R1 have on it?
Just 2.
How many?
Just 2, the serial 0, the G0/0.
That is correct. It would have 2 connected routes. How many connected routes will R2 have on it?
Well, for just the serial link, I just see 1. I don't know what's in the connection in the cloud. For directly connected, from what we see in the topology, just the 172.16.2.0 network.
That is the correct answer. From what we can see in the topology, 1, because there may be 3 in that network cloud that we don't see in this topology. But what we're seeing in this topology would be the 172.16.2.0 network would be directly connected. Very good. Okay. Default static routes. I just showed you that one, so I don't really need to go back over that. Now, summary routes are a little bit different, and using a summary route requires us to take the routes and summarize them. Do you remember how to summarize?
Yes, we do.
Okay.
I do.
So we would take these routes, convert them to binary, right? Find all the matching bits in binary, and then count the most number of matching bits, and beginning with the first one, that would be our starting network, and then we would summarize along that. Now, here's one thing you have to be careful of. Always remember that you can only summarize along bit boundaries. If you also had over here the 172.24.0.0/16 network, and you tried to go and actually do a /13, you would actually get more networks than you control. So be very careful with that. But if your summary is correct, you can just make a summary route. So you can do IP route 172.20.0, 255.2, that's 862.48. Is that right? I think it's right. 248.0.0.
Yeah, I think it's /20.
And then outgoing interface, that's 0.0.0. So that is a static route, static summary route. Now this is a very strange little beast here. By default, what is the administrative distance on a static route?
1.
So 1, okay? If, however, you go in this, let's say you've got this set up, you can actually create a static route that goes across here using 1, and then you can create a second route that has a higher administrative distance or metric than 1 that goes through here. And that you just add a distance at the end of the route command. All right. So you do IP route, network you're going to, outgoing interface, and then you just put in a number, which gives you a metric. Let me see. I think I've got this R1 may still be up. Yep. Again, I'm gonna make one up. Still a different one. 17.0.0. And see, now you can do a distance metric for this route. So if I did anything above 1, this route would be the one that would be used if I did a standard route across the top and then a secondary route across the bottom. Anything above 1, this route would not go in the route table, it would sit there, which is pretty interesting. It's an ability to use default routes to configure a floating static backup route. So again, easy commands: IP route, network address, subnet mask, next hop, or the exit interface. And you also can put a distance in here, which configures an administrative distance to change for the floating static route. Next hop options, again, are outgoing interface or the next hop IP address. Okay. If it is a fully specified route, then you do both. Okay. So this is when you actually use both the outgoing interface and the next hop, typically only if we have Ethernet between two devices. And here it is, next hop IP. And you see, one of the problems with next hop IP, and this is not as big a deal anymore because of Ceph. Remember we talked about Cisco Express Forwarding and how Cisco Express Forwarding builds a table of all the possible routes that can be used by any networks. And then as a packet comes in for lookup, it just puts it down in the table, and that table answers the question as which exit interface it needs to go out almost immediately. Before we had Ceph, this type of setup here where you did next hop IP address would be a big problem because it would cause what was called a recursive lookup. So you'd go in here and say, okay, in order to get to this network, 192.168.20, I've got to go to the network 172.16.22. So for the 192.2.0, I got to go to this network. We then have to go up and do a recursive lookup and find out where the 172.16.20 network was. Again, with Ceph, not that big a deal anymore. If for some reason you're not running Ceph, then you typically do want to use next hop IP address. Next outgoing interface. On most serial links, we do use outgoing interface because that way we can change our serial links if we need to, change IP addresses on them, and it makes no difference at all. It won't affect anything. Does that make sense? This recursive lookup, we're using next hop IP because it's saying to get to this route, I've got to go to this next hop IP address, but then I've got to know where that network is. And so it's got to go back up in the table and find that network, which was on 000. Again, with Ceph, not a big deal anymore, but in the olden days, we would always say use outgoing interface so you wouldn't have to worry about a recursive lookup. Here's directly connected when you do next do the network, the mask, and then just do the outgoing interface. Then you'll see it's a single lookup in the route table. You don't have to run back up and do a recursive lookup. And then fully specified, if this is Ethernet, you say outgoing interface plus next hop IP, and this helps with your ARP requests and other problems. So, and again, you're looking at this prior to Ceph. With Ceph, this is not that big a deal either. So, when Ceph's not enabled, this is how you eliminate recursive lookups. But again, it doesn't really matter with Ceph enabled because Ceph's going to be enabled. Verifying static routes, show IP route static, pipe begin gateway. That'll just show you only your static routes in the route table. You just do a show IP route and the actual route to a network, and it will show you what the route is for that network. How you show IP route. Here's our default route. IP route quad 0, exit interface, or next hop IP. Used on an edge router going to the network, to the internet, or to a provider network, or to a stub router. And we're going to learn how later, and again, scaling and connecting, how to redistribute these default routes into our routing protocols. So here, you notice R1 really only has one path. That's up to R2. So if I do an IP route quad 0, next hop IP, then everything that's not directly connected, I'll send up to R2. Now, R2, if you look at it, R2 is going to have two routes on it, one for the 3.0 network, one for the 2.0 network. And then R3 could also have a default route on it going up to R2. And then you would have full convergence. Everybody could communicate on this network because R2 knows about the 3 connected networks it has, and it also knows about the remote 3.0 and the remote 2.0 network. R3 would just send what it doesn't know about up to R2, and since R2 has full visibility, it could send it where it needs to go. The only problem in this network would be anything that's outside of any of the networks shown on this page, there's no route to it. Okay, so default static route, if you do a show IP route or show IP route static, you can see it here. And it also is listed as an S star, which means it is a static route, default static. So if you go down here, candidate default, S means static, star means candidate default. So that means it's a default route. And I'm going to kind of just roll through here because it's the exact same thing. IPv6 route, prefix, next top IP address, or interface. So in this case, the only thing that's different is don't forget to turn on unicast routing. Without this, routers, even if you configure IPv6 addresses on their interfaces, if you don't do this, they will not route between those interfaces. So be aware of that. This IPv6 unicast routing must be turned on. And then you're good to go once you do your static routes. And by the way, look at this. You got the same thing. You got default routes, standard routes, summary routes, and floating routes. No difference inside of IPv6. Show IPv6 route. Don't forget that. And you'd be amazed the number of times I'll add static IPv6 routes and go, man, I must have forgot to do it. And I'm putting in show IP route instead of show IPv6 route. So go in here and see those routes, see the connected and local routes. And here you can see using next hop IP route, the network prefix, next hop IP address. It'd be nice if I actually put the IPv6 addresses on this picture. So you can see them here, static routes. Questions about these because they're really not that different. Here's how we do a connected one. You just do the outgoing interface. It's the exact same thing with an IPv6. Here's a fully specified next IPv6 address where you're doing the network, the prefix, and then you've got the link local. And so if it has to link local, you're going to have to put the outgoing interface plus the link local. And sometimes we do actually route to link local addresses instead of global addresses. And you can see that route here, fully specified. Show IPv6 route, show IPv6 route static, and then those show IPv6 route, and then the network and prefix you're looking for, and it will show you those networks. So default route, a little bit different because it's colon, which means all zeros. Remember, we can replace all hextets with zeros by putting colon. And so in this case, colon/0 means all zeros. And then anything you don't have a direct IPv6 route to, send it on this path. Typically, again, a company edge router or a router with only one upstream neighbor. So a stub router. So again, here we could do this. We could do a default route up to R2 would be 6, default route up to R2 would R3, also V6, and then R2 could have one route to ACAD 4 and one route to ACAD 5, which, by the way, those are subnets of the ACAD 40/48-bit network, and would be perfectly workable and everything would be fine. Floating static route. Here's one of the big things here is remember it's a way to have a backup route. That's the only reason we really want a floating static route. By default, all static routes have an AD of 1, making them preferred above all other routing protocols, no matter what they are. So if you put a static route in, there's no dynamic routing protocol that has an AD that can override a static route. The iOS assumes if you take the time to stick a static route in, that's the way you want traffic to go. You can put a floating static route that can even have an AD higher than your dynamic routing protocols, or you could just make it higher than 1, so give it an AD of 10, and that would mean that the primary route has an AD of 1 and would get used until it fails. Then it would use the floating static route, and then anything above that it would use if you happen to have any other path. So again, here it is. You just put in the route itself, and you put in an AD. So in this case, you've got a network that says, go this way up to R2 unless that route's not available. Then you can go across this link to R3. So this may be a T1 to R2 and a T1 between R2 and R3, and this is a 56K link between R1 and R3, so you don't want to use it unless it's absolutely necessary. So, and you can see in the route table, even though you do this, you've got two default routes. One of them's a floating static, and so you see the one that goes to R2 is the one that goes in the route table because it has a better administrative distance of 1. If, however, that route goes down, then the other one would go into the route table. That's how you can test it here. So this goes down, you've got it. You're doing a trace route, you shut down this interface, and then you can see that it actually starts going the opposite way, be it 10, 10, 10, 2. If I'm not mistaken, we don't do that in this route, in this particular lab, but you may do it in a lab down the road. Okay. Same thing with V6, no different. Just put a different administrative distance. Then our host routes, we've talked about these. These are only iOS 15 or higher. And this is the actual IP address that is on the interface. Those are called host routes. Okay. And so when you put an IP address in, you get the host route. That's what actually shows up. You can also do it this way. It can be a static route to a specific destination device, such as an authentication server, and you just do a static route that is to a /32 mask. So if you're saying you want all this, any traffic from here or from this to go to here, so you can actually make all traffic here go there. Could be used for something like an authentication server via a wireless LAN controller. Go back. Okay. And that's really pretty much this chapter when it comes down to it. As far as looking up things, when you get a packet coming in, it looks in the route table. Does the route table look up? One of the things about the route table is it will look for the longest match. So the longest number of bits that will match will be used to actually forward packets. If there's a missing route, one of the things I see many times, again, remember, each router makes its routing decision based on its route table alone. Just because there's a route to the destination does not mean there's one back. So many times you see somebody else say, well, I can ping here, I can ping this IP address, but I can't ping here. Well, that's telling me that R1 knows how to get over to here, and possibly R3 doesn't have a route back because R3 is not coming back. So you just have to look at the route tables and determine what routes are where and what routes you should have. And they give you examples here showing you missing routes and static routes. This is on R1 showing the 1.0 and the 2.0 network. And then R1 has the interfaces. And then you may be able to see that in this case R2 or R3 may not have a route back. And even if R3 has a route back, that doesn't mean that R2 has a route back. So be aware of that. And just because R3 knows how to get back, if it comes to R2 and gets dropped, well, that's where it's going to go. So you can actually do a trace route and see where it stops. So again, I'll let you read through these. I'm not going to spend a lot of time. Here's a trace route doing a hop between each one, showing you where it goes. I'll also show you, yep, I knew my lab was ending. I'll also tell you that trace route is of limited use in some circumstances because if you turn off ICMP, it will not work. Trace route sends out an ICMP with a time to live of 1, and then when that comes back, it sends out an ICMP with a time to live of 2, 3, 4, so on. So if ICMP is turned off or is being blocked by an access control list, trace route will not work. So if you do a lab that has trace route, it doesn't work from your PC in your office. It may be that you have on your network turned off ICMP. It's very common, especially outside the network, not necessarily inside. Are there questions about static routes? You do have a couple labs on static routes, pretty simple routes that you see here. We are simulating with a loopback a default network that we're going to. Okay. So you should be working on these inside of NetLabs, and I believe Chapter 2 labs are due on the 25th, so you've got a week to work on those. I've already sent out the invitations for next week's meeting, and I'm available for any questions you may have. Okay, I'll stop the recording, and then you can ask all your questions.
Okay.